What is Kohlrausch law? Kohlrausch law states that the equivalent conductivity at infinite dilution is equal to the sum of the conductance of the cations and anions. Equivalent conductivity at infinite dilution is represented by lambda not EQ, not for infinite dilution. EQ means equivalent conductivity is equal to sum of the conductance of cations and anions. Cations are Na plus and anions are Cl minus. For electrolyte you can use this type of lambda, and for cations and anions you can use this type of lambda. Kohlrausch law, popularly known as Kohlrausch law of independent migration of ions. Kohlrausch studied electrolytes, molar conductivity, equivalent conductivity, conductance. We know that electrolytes having positive and negative ions. If electrolyte ions are freely moved, then only molar conductivity, equivalent conductivity, conductance is increases. Electrolyte ions having attraction forces, if we decreases the attraction forces, then electrolyte ions are freely moved. This is possible at infinite dilution. What is infinite dilution? Infinite dilution means zero concentration. Suppose if you dissolve any electrolyte, for example KCl is dissolved in water, we adding more and more water, the concentration of KCl not changes, then we call it as infinite dilution. When this KCl concentration not changes, concentration of KCl is reaches to zero. So zero concentration is called as infinite dilution. When the concentration of the electrolyte approaches to zero, the molar conductivity is known as limiting molar conductivity. So zero concentration is also known as limiting molar conductivity. If you draw a graph for strong electrolyte, take molar conductivity, equivalent conductivity and conductance on y-axis and take concentration on x-axis. Strong electrolytes are 100% ionizable. For strong electrolytes, by adding water, concentration is decreases and molar conductivity, equivalent conductivity and conductance is increases. So we get a straight line by extrapolating this line, and it is intersect at zero concentration. So at zero concentration we get equivalent conductivity, conductance and molar conductivity. If you draw a graph for weak electrolytes on dilution, Ostwald law is applied. What is Ostwald dilution law? This law states that only at infinite dilution the weak electrolyte undergoes complete ionization. That means at infinite dilution weak electrolyte also 100% ionizable. Weak electrolyte on dilution, ions are increases, mobility also increases. By plotting a graph between concentration and molar conductivity, equivalent conductivity, conductance for weak electrolyte, on dilution concentration is decreases and conductivity, molar conductivity, equivalent conductivity drastically increases. So we get rectangle hyperbola. Graphically, equivalent conductivity, molar conductivity, conductance not possible. So we are use Kohlrausch law to calculate equivalent conductivity, molar conductivity and conductance Graphically, for strong electrolyte at infinite dilution, we can determine the molar conductivity, equivalent conductivity and conductance. But graphically, for weak electrolyte, we cannot determine the molar conductivity, equivalent conductivity and conductance. So we use kohlrausch law for weak electrolyte. But kohlrausch law is applied for strong electrolyte and as well as weak electrolyte. The molar conductivity of an any electrolyte at infinite dilution is equal to sum of the conductance of the cations and anions. Molar conductivity of NaCl at infinite dilution is equal to sum of the conductance of cations and anions. What are the cations? Na plus Cl minus. Molar conductivity of MgCl2 at infinite dilution is equal to sum of the conductance of cations and anions. What are the cations? Mg plus 2 and Cl minus. So how many Cl minus? 2 Cl minus. So you have to multiply with the stoichiometric coefficient. What is stoichiometric coefficient? Stoichiometric coefficient is 2. So you have to multiply with the stoichiometric coefficient. Next, coming to equivalent conductivity. Equivalent conductivity of any electrolyte at infinite dilution is equal to sum of the conductance of cations and anions. Equivalent conductivity for NaCl at infinite dilution is equal to sum of the conductance of cations and anions. What are cations? Na plus and Cl minus. But here you don't use stoichiometric coefficient. Applications of kohlrausch law. Kohlrausch law is applicable for any electrolyte, that means for strong electrolytes and as well as weak electrolytes. If you want to find out the molar conductivity of acetic acid at infinite dilution, we want CH3COO minus and H plus. If we calculate these ends, we get molar conductivity of acetic acid at infinite dilution. For calculation, we want to use some strong electrolytes. Molar conductivity at infinite dilution of CH3COO Na, HCl and NaCl. So lambda m naught CH3COOH is equal to lambda m naught CH3COO Na plus lambda naught m HCl minus lambda naught m NaCl. Write ion for these electrolytes. So minus Cl minus plus Cl minus minus Na plus are cancel. So we get lambda naught CH3COO minus and lambda naught H plus. Like that we can calculate molar conductivity of any electrolyte at infinite dilution.